Hello again everyone, and welcome back to the workbench. Today we're going to be looking at this TV here. This is an Insignia TV model NS-42L260A13A, and it's bad. I was told that there was a loud pop and then suddenly the TV stopped working. I don't know what the issue is yet. I haven't actually looked inside, but I'm assuming it might be a cap, although it could be something else. I don't know for sure yet. I've already removed all the screws, so this back here should just come off. I believe, I don't think the base has to come off on this one at all. There it goes, the back's coming off. This bottom piece isn't releasing. Let's see. There it goes. There's just I guess a few little clips there. So that's what we have inside. There's not much. We've got the LCD controller off to the right here, the board over here on this side, the power supply, the inverters for the lamps. Up here we've got the interface for the LCD. I don't see anything visible that looks burnt just from having a quick look here. All these caps look okay. So yeah, I don't know what would have made that popping noise. Everything over here on the controller board looks, or the input and controller and stuff all looks fine. We're going to take off the power supply and see if there's something underneath that's the issue. So let me take off these screws here. Looks like we got 1, 2, 3, 4, and a little mount right there. Yeah, nothing visible right off the bat. So let's remove the power supply and see what's underneath it. Alright, so here's the power supply board, and check this out. I didn't notice it when it was just sitting there because of the fact that we were looking at it, you know, like straight on from the top. But once I actually tilted it over, there's a massive hole inside this. It's a capacitor apparently. It says C911, and holy crap, I've never seen that happen before. You can see right through it like it was shot out with something. So I guess that's the main issue here. And this cap is apparently in parallel with this huge cap right here, this 450 volt 100 microfarad cap. I don't know what would have caused it to pop like that. So I'm going to have to trace around back here and see what the heck is up with that. That's kind of weird that it would pop like that and then just stop working. I haven't actually tried to power it on because I was told that it just stopped working. So what I'll do, I guess, is I'll plug in the power cord and check the voltages coming out of it, and conveniently enough, all the outputs right here are labeled, so it'll be easy to check the power supply. There's the on-off pin right there, and then we got some PDIM. I'm assuming that's going to be for the lamp, because the lamp or the inverters plug in straight into here, so that's what would control the brightness on the lamps. And we got 12 volts ground, 24 volts power supply on. Okay, so that would be power supply on. This on and off is probably for the backlight. I'll have to trace it out and check on that. And then we've got a couple of 5 volts over here. Alright, so yeah, let's go ahead and put this on the bench, plug it in, we'll check some voltages. If I have another one of these caps, I'll replace it and see if that does anything. And just from looking at it, nothing else looks damaged, although maybe we might want to check some of these switching transistors over here, which is what I'm assuming this is. It looks like it goes to the main, this looks like it might be the main power transformer, so check that. And quick look here, nothing else. looks physically damaged. In the back side, nothing looks popped or burnt. So we'll start off with that. Check voltages, see if anything's funky going on there. Make sure we got, usually the 5 volt here will be like a standby voltage. So if we don't have that, then it's just definitely something on this board. I mean, other than this cap here, that's probably bad. Although, you know, I don't know if something on the other board would have caused that to pop. But I guess maybe what happened is this cap just developed a short somehow. I don't know, I'm guessing. And maybe took something else out with it while it was at it. I don't know. We'll find out. The board's set up here now on the bench, and one thing I kind of like about this cord that came with it is that it's got this right angle on it, so it doesn't stick straight out the bag. It just kind of comes out and then goes down. Kind of makes it so that the TV doesn't have another like bulgy cord like sticking out the side. So got our multimeter here. I'm gonna plug it in. Hopefully nothing else goes up in smoke when I do this. So here it goes, plugging it in now. Nothing so far, so I think we're good. Well, I mean, I guess as good as it gets for this power supply. Let's check this voltage here. Gonna touch the ground ones. Which, we got some ground right here. And let's touch one to the 5 volt, and sure enough, nothing. Let's check the 12 volt just in case. And nothing. It's completely dead. Alright, so, well, let's check the fuse. Let's see if this fuse is even any good. It might have blown the fuse when that popped, and that could explain why the whole thing was dead after that. Because these are going to be for the input. After it gets goes through some of this filtering here, and it hits this diode bridge, it gets rectified, goes to this transformer right here on this side. And let's see, let's trace it out. So sure enough, yeah, we got a little jumper going from here to there, and then we got a few jumpers going from, let's see, that side would be the negative. So this side is negative, that side is positive. The negative goes through this jumper, goes across to here. Oh, the jumper's right here, goes across to here. So that's going to be the negative of the cap, sure enough. Yeah, negative. And then the positive, and so that cap is right across those two right there, negative and positive. If that shorted, this is these are in parallel. These caps are in parallel here, so we got both positives connected together and then both negatives connected together. So this cap shorted straight across the positive and negative output of the bridge rectifier here. So it's very likely that it blew this fuse. And let's just check it and see. And it's wide open. So this wasn't a very exciting fix, I guess, if that's the only issue. And then the fuse. So we'll replace those, and then we'll see if we're getting that standby 5 volts that we're supposed to be getting. I've gone and removed the cap and the fuse, and I don't know if you can notice it. You might be able to notice it, but there's kind of like a little bit of a dark spot in this area of the board right here. And I think that might have been from when the cap blew, because this stuff here just kind of wipes off. And so I think it was some residue from when the cap popped. The only thing that kind of sucks is that the way the cap blew, it popped like right where the numbers that denote its value were. Although if it's this one is like just about similar size. It's actually about the same size as this one here. This one's a 10 nanofarad cap. So I believe that this one was probably the same thing, because while this one here was a parallel across with these caps, then the positive kind of jumps over here using this jumper. It goes through this resistor, and then it goes to that cap. So that's the negative side, and this is the positive side of going here through this resistor. And so I believe that this is probably the same value cap, and I don't happen to have one in my stuff. I have to do a little more digging to see if I can find one. But I think if I just replace the fuse I should be able to test the output here. From looking at the trace, like the traces here on the board, it doesn't seem like anything else going bad would have caused this cap to pop, just because of the way it's wired in here. So I think what happened was that this cap just shorted on its own and just blew the crap out of everything. Well, I mean, like the fuse, it just obviously it just shorted the input coming in. I'm going to do a quick diode check on this MOSFET here, but I don't think that would have been affected at all, since it's, you know, just the input that's getting shorted here. One thing that kind of sucks though is that the fuse that was here, you had like the two little caps, the little ceramic fuse that had two little caps on the side and then like down soldered into the board. Well, obviously I don't have anything like that, and I mean, I'm sure I could probably maybe order some or whatever, but I just got like a regular ceramic fuse of the same value. It's a 5 amp fuse, and I got these little mounts off of another power supply board from like a PC power supply, because I have a ton of those laying around. And what I can do is just a little bit of modification of this board and make it so that this fuse is easily replaceable in the future. Unfortunately, the original fuse, the leads were a little bit wider than where these pins would sit. Let me zoom in a bit here on the board. But on this side, oops, sorry, there is, oh dang, let me scoot the camera back a little. See, on this side there's quite a big chunk of copper here. So if I enlarge this hole a little bit and then make another hole a little bit higher up, and then on this side make a hole like about here and then make another one a little bit lower down, then I could actually mount these holders onto the board and make it so that this fuse isn't such a pain to replace in the future in case something happens again. So I think that's what I'm going to do. And what I'm going to do first is, once I do that, I'm going to use a regular, just fast flow fuse. This is the same value, 5 amp, and pop that in its place and just plug it in and test and make sure that it's doing what it's supposed to, and see if we're getting 5 volts out of here. So let me go ahead and do that real quick, and then we'll be back. Alright, so that's that. Drilled out the additional holes here, and on the bottom, all I'm going to have to do now is scrape the copper here a little bit so that I can solder that one on. And as you can see, this actually fits in really nice, just like that. So that fuse, if it needs to be replaced in the future, can just be popped out, and no worries about having to desolder anything. It'll just sit there like that. And what I'm gonna do, just to make it so that it's got plenty of support, is I'm gonna bend this little tab here. I'll bend them inwards, and then this one the opposite way, and maybe just solder like a little link of wire between here and there, just so that it doesn't really have too much of a chance of popping out. But that should do pretty nicely. So this actually ended up coming out pretty good. It's all done now. And on the bottom, I didn't bother soldering another wire from here to there. I just put a little blob of solder on that tab just so that it can't come out. On this side here, I was able to just kind of bridge it with solder, so that should hold pretty nicely. And I mean, unless if you didn't know any better, you'd think that was pretty much stock. Well, I mean, the only thing that kind of gives it away is the fact that it's got different markings underneath, but that's actually going to do pretty well. So I'm going to plug it in now, apply power. I'm just going to ignore this cap for now, since it's just in parallel with the rest of these. It's I'm pretty sure it's mostly used as like a bit of a filtering cap, maybe for like some high frequency or whatever. So let's plug it in, and then we'll check the voltage output, and hopefully we'll be getting 5 volts now. Let's keep an eye on this fast flow here, because if it blows as soon as I plug this in, then that could indicate that there's something else wrong with this unit. Hopefully there's not. And let me get this in view here so you can see it. Well, let's plug it in first, make sure that that fuse doesn't blow. So here goes, and it's in. So that should be fully energized. Let's check the voltage on the caps up here, and we should be getting a pretty good value. I would think about maybe 160 volts or so, I believe. Let's see, we'll hook one up here, we'll touch the other one there. Oh, wrong setting. Yeah, 166. So that's getting power. And now let's check the 5 volt down here, which I believe should be the standby. So here's ground, and there's 5. Sweet, that's working. I don't think any of the other voltages should be present at the moment. So this is one of the 12 volts, and that has nothing on it, and this is one of the 24, and that has nothing on it. So looks like we're good. And as I was saying, I don't really think that there should be anything wrong with the controller board on the TV, because this shorted like so much near the input that I really don't think any of the secondary side of the power supply had any effect on that blowing. So let's go ahead and put this back on the TV, and we'll see if it powers on. One thing we got to be careful with when dealing with a power supply like this is, since I had it plugged in now, these caps are going to be charged, and I just got to be really careful on the bottom not to allow anything metallic to short out any of like this section here. I'm sure it's got some resistors to discharge the cap somewhere. I haven't actually looked, but it's best to be careful, because these caps are going to hold a voltage for a bit of time. And let's just see what they're at right now. So we got negative here, and we got positive there. So yeah, see, we're still over 100. It's dropping, but if I would have immediately handled it right after unplugging the power, that could have given me a pretty nasty shock. The board's mounted now on the back of the TV again, and I've only put 3 screws on it just to kind of hold it in place for now, since I'll be removing it to replace that cap once I get a replacement. The most important screw being down here, which is the ground that connects to the casing around the LCD. We'll go ahead and plug it back in, and hopefully that fuse won't blow yet. This is still the fast blow, so here goes. And okay, good, nothing so far. And we'll see now if TV will turn on. I'm going to kind of freehand this, remove the camera off the tripod here, then we'll try turning it on. This buttons are on this side, so let's hit power, and we'll see if the screen comes on the other side. I'm not seeing anything. Maybe I need to hold it down some more. No? I hear the power supply going. Oh, there it is. Yeah, it's on. I just saw something. It's really hard to see from this angle here. Maybe if I turn off some of these lights. Alright, so I just flipped it over, and there it is. It's working perfect. So yeah, it looks like that was it. It was just that cap that shorted out and blew out the fuse, and everything seems to be working fine. So I'm just going to find a replacement for that cap, and that should do it. Put it back together and call it done. So thanks again for watching, guys, and I'll catch you guys next time.